All right, here I have an ant looking at its reflection in a Christmas bulb. So a shiny Christmas bulb has a diameter of 8 centimeters. Artemis ant sits on a tree branch 6 centimeters from the bulb. What's the center of curvature and the focal length of the bulb? Well, this is a little bit different. I'm giving you the diameter of the bulb, not the center of curvature and not the radius. So I know that the radius is going to be equal to the diameter divided by 2. So that radius is only going to be 4 centimeters. And that has to be equal to my center of curvature, which means my focal point is going to be the center of curvature divided by 2, or simply 2 centimeters. So I have the focal point for this bulb, but I have to be a little careful. This is going to be a convex mirror, not a concave mirror. So technically, I should make this center of curvature negative, and I should make this focal point negative because of the fact that this is going to be a convex mirror. So to calculate how far away Artemis is, the reason why I have to be careful is because I have to remember that negative sign in my mirror equation. So they told me that Artemis is 6 centimeters from the bulb. They're giving me P. So I start with the mirror equation again. 1 over F equals 1 over P plus 1 over Q, where I know the focal point and I know the distance P. So I'm going to rearrange. I'm going to bring F and P, this 1 over P over to the other side. So I have 1 over Q equals 1 over F minus 1 over P. Now, I wanted to work this one with algebra again because it's actually, I think, easier once you get the algebra down to put in the numbers. But I have F and P on these two fractions. F and P are in the denominator. The common denominator would be F times P. To make 1 over F, I would need a P. To make minus 1 over P, I would need a minus F. And that means that Q is going to be equal to F times P divided by P minus F. Now, you do this enough times, you'll see that there's only a couple different ways. There's only 3 ways to solve this equation. You'll get similar equations every time. Now let me put in the numbers. My focal length was minus 2. The ant was 6 for P. Then I have 6. Notice that the distance for the ant's not negative because the ant is real. It's a real object. But here's where I have to be careful. I have minus the focal point, so I have minus 2 on the bottom. So Q would be equal to, well, minus 2 times 6 is minus 12 on top. On the bottom, I have 6 minus minus 2. 6 minus minus 2 is going to give me positive 8. So I have minus 12 over 8, or 12 over 8 is going to be 3 halves. So that's minus 1.5. Again, negative number. I expect a negative number because the image will be virtual because it's a convex mirror, and convex mirrors only do virtual images. Define the magnification of Artemis's image. The magnification is equal to HI over HO. Now I don't have either the height of the object or the image in this problem, so I'll have to use the other form, minus Q over P. So the magnification will be minus 1.5, that's my minus Q, divided by P, which was 6. So this is simply going to be 1.5 divided by 6. which is 0.25 centimeters. Sorry, no unit. It's a ratio. So. Notice that the magnification is a positive number because the image will be upright. So there we go. Okay. For the last problem, I'll do it with numbers again, so we'll go back and forth. Whatever's more comfortable with you, but you know, either way, you either need to be very careful with the algebra or very careful using your calculator. Abigail ant stands 2 centimeters tall, so right there they're giving me the height of my object, and rests 4 centimeters before a mirror. That means that they're giving me P. To Abigail's glee, she sees an image that is 50 centimeters tall and upright. That means that must be an HI. What is the magnification of the image? Well, now I have HI and HO, so I can find my magnification. That's going to be 50 divided by 2, or 25. So the image is going to be 25 times bigger than the original object, Abigail. Notice magnification is positive because my height of my image is positive because it's not upside down. So I kept that positive, so it's just 50 over 2. So this problem is a little bit different. It's actually easier. What's the distance to the image? They didn't give me a focal point here. If you don't have the focal length, it's not obvious. You don't want to start with the mirror equation because that has a focal length in it. So but I have this magnification, and I know the magnification also relates the distance to the image and the distance to the object. Well, that means that this minus Q over P must be equal to 25 because that's the magnification we got from the other part of the problem. That means that minus Q must be equal to 25 times P, or that Q will be equal to minus 25 times 4 centimeters. Now, also note that as long as everything's in centimeters, because this is all based on ratios of triangles from the derivations of the equations, I don't need to worry about meters. I just need to make sure that everything's in the same unit. So my Q here will be equal to minus 100 centimeters. Now, is the image real or virtual? Well, this negative distance to an image tells me that it's virtual. And that also makes sense. If you recall in the videos, I said that from a single lens or mirror, and I don't know what this is, I don't know what type of mirror it is, but from a single mirror, an upright image is always virtual, and that's what we actually see. So I could answer this question without even really doing the math, just by looking at the type of image I get. Now I can calculate the focal length of the mirror. And I told you I'd do this one with numbers. So I have 1 over F equals, well, 1 over P is 1 over 4. And I will be subtracting minus 1 over 100. All right, the negative sign is because the Q is negative, so this 1 over Q becomes a negative value. Now I'm going to make my life a little bit easier. I'm gonna put both these over the same denominator. 1 over, if I turn the 4 into 100, then that means that 1 over F must be equal to 25 over 100, because that's 1/4, minus 1 over 100. So 25 over 100 minus 1 over 100 is the same thing as 25 minus 1 over 100. And that means my focal length is going to be equal to 100 divided by 24. Or 4.17. centimeters is the focal length. And let's stop for a moment to see if that makes sense. We said in order to get a virtual image, you need to be closer than your focal length. So this focal length needs to be larger than where Abigail Ant is standing. Abigail Ant is standing 4 centimeters from the mirror. That is less distance than the focal length, so it makes sense that she's seeing this big virtual image. Is the mirror convex or concave? Well, my focal length is positive. That indicates that this is a concave mirror. The other indication that it's a concave mirror is the fact that the image is enlarged. A convex mirror only makes smaller images. Do the reflected rays converge or diverge? Because this is a virtual image, those reflected rays are diverging. I mean, because it's a virtual image. That's all there is to it. So look at these problems. After you practice a couple, hopefully they get easier. But the first couple times you do it, it's very easy to make a sign mistake or an algebra mistake. It's not that the math is that difficult. It's just that there's a couple different steps, and it's easy to forget a negative sign, which throws the entire thing off. So if you have any questions on the problem, if you think your work is good but you can't see your mistake, feel free to send me a picture of your work. You know, I don't mind checking over your work. Just make sure it's all laid out. Be careful with your calculators, and I'll see you later. Bye.